Hi everyone, in this video I'm carrying on with this interesting question that has us looking at recursive formulas with geometric series and mathematical induction with spreadsheets tacked on at the end. It's a 6-part question. In this video I'm working through part 3. So if you haven't already watched my videos for part 1 and part 2, I'll provide some links so that you can take a look if you need to. For this part 3 we're told, with the exception of one term, the remaining terms in your expression for f of n should form a geometric series of n terms. Find the sum of this geometric series. And then we're told, just by way of background in case you didn't know, hopefully you do, but just in case you don't, a geometric series is a sum of terms where each successive term is generated by multiplying the term before it by a constant value. This value is called the common ratio, denoted R. The beginning term is denoted as A, and the sum to n terms of a geometric series is given by Sn equals r to the n minus 1 on r minus 1, where r is greater than 1. So that's basically giving us a very helpful hint here, although I suspect if you were doing a question like this in a high stakes exam, it's very likely you'd be expected to know this. You wouldn't be told it. I guess it depends. But here, what we really need to do is take a look at what we got from part 2, and we're focusing specifically on what we're kind of nudged to realize is a geometric series. So this part here of our expression of Fn is a geometric progression or geometric series. And so what we want to do is find the sum of this part. So for part 3, we can say that we have a GP, a geometric progression or geometric series, with the first term A in our series is 1, and our common ratio, the constant by which each previous term is multiplied, hopefully you can see, is 4, because we take 1 times 4 is 4, 4 times 4 is 4 squared, and so on. We're always having this common ratio of 4. So now, and also we've got n terms, because even though we only go up to 4 to the n minus 1, we are starting with 4 to the 0, or just 1. So it's, 1, 2, 3, and so on, all the way up to n terms. So we've got with n terms. So there are the components that we need to then use our sum of a GP formula. Now, because we've just got this generic n terms, we won't have a number for that, but for A and R we can substitute in. So we'll get the sum of this geometric progression with n terms will be equal to, we're told in the question that the formula is A r to the n minus 1 on r minus 1, where r is greater than 1, which we do have. R is 4 for us. So let's just substitute in. So we'll get that's equal to, for us A was 1 times 4 to the n minus 1 on 4 minus 1. That's just substituting in A and R there. So I can just write that as 4 to the n minus 1 on 4 minus 1 is 3. And that's as far as we can go, because we don't know n. We can't simplify this any further. So that's it for part 3. Again, pretty straightforward, especially given they told us this formula here. So it's really just a matter of substituting in, being able to realize for our GP what was A and what was R. Once you know that, pretty straightforward substitution, and you end up with your expression for the sum of just the GP component of our f of n expression. So that's it for part 3. Hopefully you're able to follow along with no problems there. In the next video, I'll take a look at part 4. All right, tick boom.